Hi everyone, welcome back to IoT and cloud computing session again. So in the previous sessions we have seen about few of the infrastructures where the cloud computing has been supported. So let's start with how are we actually implementing the cloud computing in these sessions. Okay. So before I start with implementation, what exactly the implementation of cloud computing, the vast division of cloud is like this, something we call it as public cloud, a private cloud and a hybrid cloud. I think when you have seen my past sessions here, so I was been addressing about we distinctly have 3 clouds in the market where all the companies or big industrial companies have been actually trying, and I mean an IaaS or platform infrastructure or software as an infrastructure also do have and do maintain with public, private and hybrid clouds. Now let's quickly understand what exactly a private, public and a hybrid cloud and where do we actually use them in our daily to daily activities, right? Okay, let's coming to the question from everyone's perspective, what is a public cloud is of? Okay, so the public cloud is a IT model where on demand computing services and infrastructures are managed by a third party provider and shared with multiple organizations using the public internet. Okay, so the main concept here is a public internet. So I maintain an infrastructure. Example, if I am the company owner which is actually trying to give you the public cloud infrastructure to the other X person. Okay, so I maintain the infrastructure, I maintain the software, I maintain everything, but I being as a third party provider will share to the multiple organizations sharing this on a public internet. I think the shareable IPs or the public internet access is being open for all. Okay, so we talk to each other via a public internet. Okay, so the public's so when we just see into the slide, even the public cloud services providers may offer a cloud-based provide services in an infrastructure. So platform as a service, or either it can be infrastructure as a service, or either it can be software as a service to the user. So you pay monthly, you pay yearly, or you pay as your use. So eliminating the need of the users to host their services on the own data center. So I own my data center, I'll pay for my instance and I'll pay for my bucket, I'll pay for my storage, I'll pay for the memory which I'm using virtually. So this is what is a public cloud, and it do have a public access to everyone if I'm actually using a public data. So when I actually go for saying a public cloud, most of the students or engineers who are actually in a learning phase, they can actually opt this public cloud as a domain, because people, I believe when you're actually a student or an engineering working up, so you basically don't maintain any privacy of data. So as you can go with the usage of public cloud in your project creations or in your thesis or in your research papers. Okay, so this is what is a public cloud. Now why the public cloud? The question comes here is, okay, theek hai, I have done and understood what is public cloud. Now why only public cloud? Okay, so many of the enterprise business looks to the public cloud to scale and exercise an IT resources. So demand without committing to expanding to their physical IT infrastructure. Example, I have raised my own company with 10 or 15 resources, but my budget is bit lesser for me and I can't maintain and hold up certain infrastructure for all the resources and give them all the setups and make them do it. That's where my cost limitations do come. But what I do is I don't actually try up taking an infrastructure from my own and I put my cost or I put my energy or I put my everything on top of it. I'll just go back and say, I just need your space, please rent it to me. So this is where is a public cloud. On an access of public domain, I'll use it. On a public IP, I'll use the storage and I'll keep continuing the data access. So this is what actually the statement we call it as, instead of purchasing physical desktop machine and a company purchasing a virtual desktop license, I'll only purchase a license of the virtual thing. So I need not to go back, purchase the licenses of all the tools which I actually have to install in my OS or any of the things. So these all headache actually I'm nowhere needed to do it, right? So I'll just go back, purchase and keep it aside, that's it. So public cloud is actually a popular solution for the storage needs, since data storage in the public cloud is accessible anywhere in the world. Now I been in India, or I've been out of India, or I've been any of the place, I'll just go back and touch back and see the data, because I am open to access the data anywhere in the world, because it's publicly accessible on a public internet. So that's where accessibility, scalability, reliability, storage, everything comes and sits back onto the same plate, saying public cloud is the best usage for the upcoming phrases like you guys engineers, if you're actually trying to do your projects on top of your cloud computing, right? Now, the viable question again, why the public cloud? I already told you it's a low equipment purchase cost. So when I say low equipment, because employers are only accessing the resources which are sitting on a other place, you need not to maintain, and the lower maintenance cost, right? So if you have actually taken an infrastructure and you have taken a machine, or you have to maintain it, you have to sit back and see how it is actually working. If you really got an issue, you should look back and see what is exactly the issue is. So these all the maintenance cost, equipment cost, software cost, licenses cost, these all will get narrowed down when you actually rent up a virtual machine and do your instances there. Okay. So now how actually these public clouds work? Okay. So public clouds rely on a virtualization environment to provide extension. So different strengths we have while talking about a perspective of, so companies considering migrating to public clouds need to be very careful considering the option, choosing a provider that it's been locked for long term or contract base. So if you're going for a long term usage or contract base, or how much time, so that you should be pretty good or clear about it. If at all you have purchased an instance and you start keeping on using it for longer, so depending on your usage, your billing would definitely happen across that. So because the servers in the public share a data to the multiple companies with security in a public cloud, right? So the stronger the security, stronger the access of data you really have been in public cloud. But I'm just talking about viable data transmissions here. Encryption is something a very good way to own the data security. This data security is again a big subject when we talk about all the cloud computing domains. See, security is something which is actually stopping the vulnerability or any other X factors to happen to corrupt your data or to consume it data, or from the hackers or anyone. That's where is a security comes and sit in. There where even the companies play a very crucial role encrypting the data which you have already shared and storing it in some places, so that you again decrypt that and you will see that data. That's where the security always pitch in all the clouds you really have. Okay. Now the next thing is, what is a private cloud? So private cloud is known as an internal cloud or a corporate cloud. Okay. So it is our biggest term in computing architecture. See, if example I have a bigger organization, I have certain data should be very private, it shouldn't be seen by someone else, it should be very highly confidential. So I'll go up and say I'll create a private cloud. So that is what is called, so this is accessible only by the single customer who is making the cloud by themselves. This is where we call it as private clouds. So the private clouds are something where the orgs basically, the biggest big scale orgs or the MNCs levels orgs, and the highly secured organization or industrials which they want the data to be so secured enough and that shouldn't be accessed by someone else. They basically go with the private cloud, so creating their own clouds by themselves and keep everything on demand and control security, resource, customization and premises configuration, everything they do it by themselves. Okay. So by building a private architecture according to cloud native principles, so we can create our own cloud, and I can even talk to a public cloud. It doesn't mean that if I have a private cloud, I can't talk to a public or a hybrid cloud. So I have a provision to talk to private, public and hybrid at any level. But the thing is, when you are actually talking from a private cloud to public cloud, there can be a security vulnerability that can be addressed by few of the security aspects also, but that will dig on to the next slides, maybe few. Okay. So there is a possibility of data transfer from certain cloud to other clouds also. This is what is a private cloud. Now how exactly a private cloud works? So as I told you, for the public cloud, there can be having multiple tenants. Okay. For the single owner, there can be multiple tenants. paying for what they are actually using. So for the single house, there are multiple tenants and they are paying rent for the house. Okay, but for coming to the part of the private clouds, I have a only single tenant environment. All the resources are accessible to only one customer. So this is what I referred saying that isolated access. That's it. No one else has an access to that zone. So you will be only having access to that particular zone. So private clouds are typically hosted on premises, so customer data center. But private clouds can be hosted in an independent cloud provider infrastructure. So managing models may vary. So how do you manage your private cloud depends on the company infrastructure, your management, your service providers and all, or your applications. That's where your cloud management things comes up and say it depends on your organization. How are you trying to make your private cloud so feasible for the employees or the other exposures. But the main motto of private cloud would be the data collection and storage for their own understanding and analysis and data. Now I'll go for another major thing, hybrid cloud. Now why does hybrid cloud came up? So this is what leveraging both public and private clouds here. And why are we leveraging public and private cloud is because, so I have few things in private cloud, I have few advantages in public cloud. So combine both of them, mix it them, I can give you a better performance and better outcomes in a hybrid domain, right? So when you just see this, in a hybrid cloud, I have written a benefits of what exactly. It is fully customizable, robust management, secure by design, right? It is what is a private. The security is actually the biggest plus in the private cloud and it is customizable. A resource or an engineer can customize its own cloud by himself and it's robust to manage and it is security with design. Now coming to the public cloud, it is low entry cost. The costing is actually less. You will only pay for what you have used, pay as you go, and highly elastic. It is elastic because it works with the public internet. So lesser security aspects here, so big risk. So when combining both of the infrastructure, you will be having hybrid cloud as a better outcome. That is, you will get a benefits of scalability, flexibility, security and cost efficiency also. So this is the best thing, right? So we got a security aspect here, we got a cost efficiency here. So the concept hybrid came up in few of the organization considering I'll take an aspect of security from private cloud and I'll take an aspect of cost efficiency from the public cloud. So this is where the actual hybrid cloud came into picture. So most of the companies are even trying to use a hybrid cloud to talk within themselves with security and outcomes of cost also. So this way more of the organizations are nowadays being involved. So this is what is actually the gist of what exactly the clouds we have. And whenever I'm talking about the infrastructures which I was discussing in the previous presentations, those three infrastructures do depend on these three cloud types also. Okay. So the notable cloud services, maybe we have a pretty good number of notable cloud services in the market. So many companies are delivering services from cloud. Some notable examples I have just listed down. Either if you go for a Google, it has a private cloud and it uses to deliver Google Docs and many other services and users. Like I think I've told you, email accesses, documents, text translations, maps, web analytics and much more. This is where is a private cloud. So Google maintains its own private cloud in the market with all this applicant to be provided. Even a Microsoft has an Office 365 online service that allows you to business intelligence. So this is also a big concept, making a public or a private cloud. So Salesforce, it is something as I've told you, runs it's an application. I think I've addressed you saying it is a part of PSS and runs an application in custom cloud, and it is actually we basically use it to develop our own applications and platform to build a customized cloud. So this is what some of the notable examples which I think we have discussed before also. So considering all the clouds and all the types of clouds and all the infrastructures, I have just narrated the picture like this. So there is a SaaS, PSS and ISS. See, when you can see what exactly I do. Now I'll just come up and gist of all these things. Maybe you would have missed my previous explanation. So this is what is the gist of all the explanations which I've done till now for infrastructure and cloud related stuff is one infrastructure zone is IaaS. That is where I am telling where our virtual machines or servers or storage or load balancers or networks come here. Okay. And PSS is something execution runtime database with web servers and development tools, which I already told you. Few of the software developers are much more involved here for PS and IaaS. And SSS, I told you email and virtual desktop communications or the game zones. So this totally comes into application. So these all the things are talking to some cloud clients. So we are those cloud clients like mobiles, our web browsers, our search engines, our tablets or terminals or our any of the emulators do come in a cloud client. So we are an ex-participants for the cloud clients talking to these are infrastructures. So this is what is a very high level architecture where each cloud and each type of cloud is talking to each type of infrastructure. Okay. So this is where is a virtual representation of what we actually talk in words, saying what happens exactly inside the cloud. Now I'll quickly make you understand. Now okay, you are telling me what is this, what is cloud, what is infrastructure and everything. Now how do I actually know, create a cloud? How do I actually know what is the cloud is and what exactly happens inside the cloud? And if I do, I have to code something, do I have to write something, how do I do it? I'll give you a small example with Amazon services itself because it's a pretty elastic computation technique what we really use. What is this EC2, sorry, EC2 is elastic compute cloud, is a web service. I think pretty good number of people has heard about this. And it's a resizable computing capacity that users build and host different software systems, okay, and designed to make a computing easier for the developers. It's an easy instance EC2. Example, if I have taken an elastic compute cloud and I have created my instance, then I'm started paying for my instance. So I'll tell you, I was just addressing before that also, I'll tell you what exactly an instance is. So when I talk about instance is something I'm creating my space inside that virtual box, whichever I'm talking, the virtual box is somewhere inside around the world, it can be anywhere. Now I have my own instance saying, example, I have to capture the sensor data and log all the data, example a smart meter. I am just trying to collect the data of a smart meter of current or power or anything and I'm just plug. I have just connected the plugin, I have started collecting the smart meters data inside my cloud. Okay. So it started collecting the data and in a web scale way it started collecting. Now I have created my own instance. In that I have created my space, I have created my bucket and I am just throwing all the data with certain UID which is already given for me when I paid for particular service to opt it. So either of any of the cloud will come up saying few of the resources. So example, I'll tell you, Amazon will come up and say, I'll support few of the resources, I'll support few of the capabilities, I'll support few of the infrastructure. Then I'll say, okay, for my project, I only need particular infrastructure and then I'll come back and purchase that and I'll go back. I'll do the analysis and I'll put all the data inside my infrastructure, which I have already created, right? So this is what we call it as elasticity. So scales in both the direction. I'll generate my data, keep it into an instance, and instance will keep analyze, and I can even trigger my instance to give certain output to me also. That is what action to your reaction, right? That where we address something like senses and actuators or sensors. That is called sense, action and sensing and giving the reply for the same. Okay. So let's quickly understand what exactly EC2 infrastructure concepts we do have. So we basically have a EC2 infrastructure concepts as EMI instance, regions and zones, storage, networking, monitoring, auto scaling and load balancer. Now what are these all? So these are not only as part of ES2 concepts, but these are the concepts of all the cloud related instance creations. Maybe you can verbally change few of the nomenclature would have changed, but the concept behind the each heading be the same. I'll talk about Amazon machine images, which I'm just talking now. So Amazon machine is something is an immutable representation of a disk. where operating systems and applications and data are on the, if you can see that image, I have an AMI machine where I have a template and it's actually talking to different launched instance types with larger instance, some high performance CPU, some high memory double extra large instance. Example, for your project you are needed with a highest performance CPU instance. So depending on your input of the data, it will try to talk to that particular virtual instance directly. You need not to train that module to talk to that particular CPU only, because you are nowhere aware of the hardware, what it is and how it is, right? So depending on the input of the data and the payment of the service which you have actually done, so it will fetch the hardware which is actually having. That is what we call it as a machine image. It's an immutable representation of disks. So from an AMI we can launch multiple instances which running copies of AMI. So that's what I told you. From an AMI I can run multiple instances of mine, and I can create multiple instances. One can be larger, one can be smaller, one can be higher performance, one can be minimal performance, and that differs with different project analysis which you actually do it. Okay. So coming to the instance AMI creations, we have a host host computer with certain instance and the launch instances for any type. So this is what is actually a very basic narrow down of instance creation which I was just addressing before. Okay, something like virtual servers in the cloud, and each instance type offer different compute and memory facilities here. Okay, so whatever I was just telling now, okay, if you can see on this, see on it, these are the wide distribution example. So these are only the samplation, these are not exact configuration. Example, I have type of the usage of your cloud, you are saying it is small. Okay, and your memory is only 1.7 GB usage you are using. So what it will do, it will filter accordingly your CPU usage, your memory, your local storage, and it will search for the option, and even for the larger, extra large. So depending on the data utility, your memories are allocated and your GBs are allocated, your high performance CPI. So hardware differs with the usage of your instance creation. And the other good topic is something called, we call it as region and zones. Region and zones is actually an interesting just topic, because Amazon or any of the thing differs with the data centers. It doesn't mean that I have a virtual machine in this particular place only. The places do differ, the regions do differ, the zones do differ, but the thing is the data is sitting onto the cloud on a virtual machine is a common concept here. So Amazon have a data centers in different regions across the globe. So for instance, can be launched in different regions to meet the legal requirements. Okay, and to choose a customer specific applications, that's where the zones comes from. So inexpensive, low latencies and connectivity between zones and regions will come up in this particular perspective. Okay, this is where I'm just talking about regions and zones. Specifically as an engineer, you need not to be worried about it, but I'm just giving you just an info about it. It even do differ with the regions and zones also. Now storage. Now how exactly, if I given a data for my sensor data or for my collected input data, how is actually the cloud is storing it into? Okay, so when I just coming to the part of AWS or Amazon instance creation, there are three types of storage options I have, which it officially gives to us, saying it's Amazon EBS, Amazon S3 and instance storage. I think I have just narrated in the picture here. When you come about an instance storage, it's your host PC, it's instance AB are talking to the alphanumerical storage boxes here, right? So the instance creation is something like this. So EBS is talking to host computer and Amazon S3 is talking to the snapshot or bucket of your EBS. So I'll just explain you what exactly EBS and S3 is also in the upcoming slides. So why do we actually call these all storage buckets? Okay. So let's talk about what elastic block storage volume mean. So elastic block storage volume is a read-write disk that can be created in a AMI, okay, mounted on an instance. So volumes which suits your file system, volume which suits your database, volume which suits your level storage will be setted and collected there. It is called, we actually call it as elastic block storage. Elasticity means depending on the consumption of the instance, depending on the data, depending on instance creation, you actually EBS volume get kept keep increasing on a snapshot. Now, what is Amazon S3? S3 is something simple storage service. Most of the people are aligned to S3 is a simple storage, or it is only service oriented. So, something like web services. So, if I go for usage of an architecture with web services, so it allows you to read, write, delete or write permissions on the single object. So, something when you're browsing your web service, so that's where you are when you're working with the protocol of REST or SOAP protocols for messaging and all. That's where your S3, Amazon S3 will fit in. So, coming to Amazon Simple Database is a highly available. So, most of the people are flexibly using this Amazon Simple Database because this is non-relational data and store that work database administration. So, creates and manage multiple geographic distributions, so durability and consumption, maintenance, storing, reliability and all these do comes and fit into this simple database. Okay, now the major topic would be networking and security. How secure you are when you are throwing some data onto the cloud. Even you worried about when you are doing your WhatsApp convo or any Facebook convo, you feel that how secure am I to send my data onto the cloud? Does it really worthy to send my data onto the cloud? You people are worried about it, right? So, that's where the networking and security do come. So, instance can be launched in two platforms. One is Elasticity or VPC, I am saying. This is what is a sampleation example that what exactly we can. So, example, each instance is launched with two of the IPs, two of the addresses. One is as private address, one is a public addresses. A replaceable instance which I create will have a public IP address. So, IPs are different here, private address, public address, replacement address, right. So, whenever instance IP is dynamic, a new IP is assigned for every instance. In example, I have created an instance, I have again created an instance, so IP dynamically changed. What happens if IP dynamically change? So, I have been so secured, right. The rolled out action or the data which has done on the past IP, now it has been changed to the other IP. So, I am just forecasting that my security is being secure. I am with secure zone that okay, for an instance my IP got again changed, no one can go back and search back on the same IP and see what data is being exchanged. So, that is where the security and networking security do come. This is again a bigger subject, people who wants to work with the network security, the cryptographic algorithms or security algorithms on cloud, and this is again a bigger subject to deal with you like engineers. If you guys are really interested to work with network and security, the algorithms do differ and you can work with the security. So, this is again a big subject for application engineers and even the security network engineers too. So, monitoring, auto scaling and load balancing. So, monitoring the statistics and instances in EBS, something like cloud watching as you already told. Automatic scales and capacity zoning. So, auto scaling is something you scale yourself across multiple instances and load balancing techniques. Okay. So, how to access EC2? I will tell you what exactly AWS Cloud and AWS Console are. Example, I have an SOC, I want to send my data to the cloud. So, I have my chipset ready with Wi-Fi and Bluetooth and everything up with me. I wanted to send some data and send it to cloud, and I have a board ready with me. Okay. So, example, if I have a readily board available with me and I want to talk to an AWS cloud, what do? So, AWS will be providing you a certain SDK. SDK is something, a code base where it will give you provision to talk to that cloud with some APIs, some code base, something like I call it as wrappers or APIs or whatever you call it about your convenience. It gives you a set of code. Now, I will take that set of code and I will put my own board level APIs inside it, and I will make my board ready to talk to the cloud with these APIs via some connectivity. Either it can be Wi-Fi or either it can be Bluetooth or either it can be Zigbee. Now, the data is being thrown to the cloud. So, that is where actually things happen. User interface can be something different like command line tools or API extensions or SDKs or console, what not it can be. So, utility and usabilities are different, coding is different, implementation is different, user interfaces are different, data analytics is different. You can see an example of AWS management console here. because this is something like if you create an instance, how does it exactly looks? Something if I have, what is your zone type, what is your security group, what is your status of the instance running or not, and your owner ID, your virtualization thing, are you using a web service, or how much normal it is been running off, and what is your ID of the kernel, your hardware, your root access. So all the details will be created here when you actually create your own instance inside the cloud. So there are, if you can see, there are different instances in the cloud side, like S3, EC2, VPC, and different instances here in the dashboard also. So once you open your any of the AWS cloud connectivity IP, you can see these all the details. Now the next interesting and the biggest topic is, now we have actually seen what is cloud and what does it do and everything, and how to set it and all. But the thing is, what happens? What do we do with the data which is already stored inside the cloud? That is what is the topic called data analytics. Now data analytics is again a big subject here. So it's a science of analyzing raw data to make some conclusions. Okay, now we have collected some data, but what do we do with that data? I should do something with that data, right? See, keeping on collecting the data of no use when I sensibly don't use it anywhere in the market. So I collected the data, I gathered the data, now I am filtering the data, now I have to conclude on where I have to use the data. That is where we call it as raw data, to make conclusions on where we have to use it. Okay. The techniques and process of analytics have been automated in the mechanical process and the algorithms also. So there are pretty good number of algorithms and pretty good number of technologies rolling out for data analytics in the market. Good programming languages to analyze how the data is. So there are n number of algorithms being developed by other developers in the market nowadays. So how do we analyze that data? So your data analytics do differ with respect to the type of data you are giving as an input to the data analytics. Okay, so that is what this slide shows you about the data analysis steps. The first step is to determine the data requirement, how the data is grouped. Okay, so now how are you grouping the data? The data can be something viably different, like it can be your sensor data, it can be your smoke sensor data, it can be your biometric device data, it can be something raw data which you're collecting from a satellite, if you're raw data which you're collecting from a home automation system, raw data if you're collecting from an industrial zone, it can be any type of data, but you have to group it according to the inputs which you actually want. The second step is data analysis, is process of collecting it. So once the data is collected, it must be organized. So collecting the raw data is one phase, and how do you organize the data is one phase. So once the data is collected, it must be organized so that it has to be analyzed. So collection, analysis and organization comes in a one-by-line state. So, and now the data should be cleaned up. Data should be cleaned up just because to make the algo understand what should be the next action. So this is where pretty a number of languages are there in the software market to groom these data. This is again a big subject. If you would have heard like big data, there are so many words talking to this data analytics, right? So big data. So there are so many subjects in the market rolling out for data analytics. If you guys are really interested to put your heads and understand what is this data analytics is. So data analytics is a very basic scenario which we are talking about. Now we are talking about types of data analytics. Is broken down into, there are 4 basic types we actually have. So descriptive analysis, diagnostic analysis, predictive analysis, and prospective analysis. Okay, I'll quickly explain you what is descriptive analysis. Descriptive analysis basically need to describe, okay, are sales stronger than this month than last? So if I have to analyze saying that my organization sales are stronger than last month or not, I am in loss or a profit, so I have to scale back. I have to describe myself in an analytics form and understand and decode my data. And the other one is a diagnostic analysis, where somewhere we call it as a marketing strategies or sales or hypothesis or diverse related stuff or image impact. If you can be your weather forecasting sales. So all these things which we call it as diagnosation, depending on the diagnosation, I'll collect the inputs. Then coming to the predictive analytics. So this moves to be likely to happen in nearby terms, what I call prediction, like hot summer. What are you really predictably having in the next weather forecast service? That is something like predict. So depending on the present data, I'll predict my future, try to predict my future. Maybe by tomorrow the weather forecast would be like this. Maybe might be tomorrow by this time I'll get few drops of rain. So this is what is your prediction. Okay. So now the perspective analysis is, this suggests a course of action like something like 5 models of 58% we should add an additional tank or increase the capacity. So this will give you a suggestion that you should definitely increase the capacity of this zoner to this much, so to improvise from this action. So these are certain analytics I'm just listing out. I'm not saying these are the proper listing out analytics. This is a very basic analytics where the data analysis was happen. Okay. So if you can see, there are data analytics where some of the languages or tools we do support, like Hadoop. I think you people have already heard about Hadoop. I think pretty good number of posters we're actually getting to see in all the way while we going travel. So also software courses you would have heard about Hadoop or Apache Spark, or so these are all some MongoDB. So these are all some basic data analytics related languages and tools which do understand and make us to train how we can groom our data, how we can clean up our data, how we have to analyze our data, how we have to predict our data, how we have to put our data, how we have to filter our data. So these are concepts being covered in all this data analytics perspective. Okay. The last concept of the cloud computing, I would say this is user interface. User interface is something with in a very broad picture, I could say it's a utility where a customer can see the output. Something like if you can see your Amazon app, if you can see your Flipkart app, if you can see any of the grocery store app, if you can see any of your chat box apps, right? So how would you see that as a UI? So the UI visibility will differ depending on the usage of you. How do you actually put your interest on it? So depends on the user interface. So these are the languages may useful for you to write your UI applications, like something like Node.js or AngularJS or MongoDB or some Express. So there are pretty good number of number of languages in the market to write these UI applications, but I'm talking about very few examples here. So these are the languages where they come up and say, now what do I show to the customer? And how do I show the customer, and how can I make a customer easily look into my app and understand? It shouldn't be so confusing for the customer to purchase something from my app. It shouldn't be so confusing for the customer to come and say me something. So that is where is UI, making your own functional arrangement to display. Example, if a grocery store is giving you an order of this list of products you do have in the grocery store. Now you're trying to add each and everything in your cart. So how user friendly it is making up the cart to be ready. Now how are you adding it? How are you searching the product? How are you searching a grocery inside the search bar? You search and add it. Now if you're trying to search a grocery in your own language, does it actually been optable there or not? And what if I have to again narrow down my language and write my grocery name and search in and add it to the cart? So how difficulties you're facing, how the market is trying to narrow them down. This is where your user interfaces will come into picture. That is where your best languages do come. Something like JS or everything sit in here. So these are all the biggest subjects which we have in the cloud computing, containing user interface, data analytics, IoT as a device, cloud computing with all the clouds and all. Now, just in all my presentation, I would narrow down and say what is the benefit of a cloud computing. Now, you have told me all these things, and can you please gist it down and say what are the benefits of a cloud computing? So, cloud does not have to worry about buying anything. Sorry, client doesn't have to worry about anything. He has to pay for what he has to use. He can access services anywhere, anytime, anywhere he wants. So, but he can't own it. Ownership is not in our hands. We can rent the services, we can use at any time, anyway, how much amount you want, you're free to use it, but you can't own it. is a point in cloud computing benefits. Okay, and disaster data usage is usually not a loss of your data. So losing of data is primitively very, very minimal and easy to develop your own web-based applications. It is highly automated. Just because you have to sit back and create your configurations, that's it. Now you are ready to use. Now cloud computing frees up your internal storages. Now I have kept so lot of things in my internal PC, but I need not to actually maintain, push them everything into the cloud. You need not to maintain your infrastructure in your local PCs, right? So it basically helps your business to become mobile. There's one word, the best word I actually like, this cloud computing helps business become mobile, because you are ready to access your data anywhere, anytime, anywhere in the world. You can actually be compatible enough to use this data. This is where we are just saying cloud computing benefits. Now, for every system, we have a benefit and we even have a drawbacks also, right? So what do I really have a drawbacks of a cloud computing system? Often limited or no technical support available. Sometimes, depending on the cloud which you have opted, there can be a no support in technical aspects. If you're really not getting any technical support, yes, this is a drawback. Okay, and when there is a technical glitches or any technical issues or any internet or data issues in the application, if they are not addressed properly, yes, this is an issue. And no control on the traffic. Accessing speed may be limited when multiple users are trying to use the same cloud, the same instance. There can be clashes and glitch in the cloud at some instances. That is very minimal, but if it is there, yes, it's a disadvantage. Okay, and if a company is hosting an application of a business and if there is a minimal data loss, and the data loss can be permanent for some instances, very minimal, but yes, this is also a disadvantage. And you should definitely have an internet connection. And all these presentations do rely on the same word. Yes, you guys should have an internet connection. Despite of that, no other way to access any of the IoT devices in the market, any of the IoT devices in the cloud. Okay, so this is where is a drawbacks, what we call. Now, you have told me about all these things. Now you, as students or engineering graduates, you come back and say me now, okay, you told me the big subject like cloud computing. Now as a student, if I have to do a project on my cloud computing, or if I am planning to build my career in cloud computing, how do I do that? So why should I pursue my career in cloud computing? What is benefiting me to choose a cloud computing as my career, right? So I'll give you a very approximate organizational chat percentage. Approximately 96% of large organizations use at least one form of cloud computing within their operations. So 81% of these companies have invested in multi-cloud strategies. These figures could rise in an upcoming years depending on organizations' realize true potential of cloud computing and success scalability. Okay, so the major words here addressed are approximately 96% of the large organizations are investing onto the cloud computing domains. So this actually means is that people are ready to own up the particular clouds, and people are ready to take the resources who are actually working on the cloud with multiple languages, multiple softwares, multiple tools, who are capable enough to work in their careers, are ready to take, are welcome to the biggest institutions or organizations or small scale orgs also, where they are ready to put their IoT stuff inside their orgs. Okay, so the career growth, yes, is the biggest plus in the cloud computing. You are ready to be taken at any time once your skill set is so sufficient enough to put yourself in any of the domain where you actually fit in. It can be connectivity, it can be data analytics, it can be user interface, it can be protocol level thing, it can be IoT device, or it can be any of the field which fits into IoT. So IoT is not something talking about only cloud part. IoT is something which talks about a very wide range of technologies, including the hardware design, including the connectivity part, and including the applications, including the data management also. So along with significant cloud technology, so few of the business have a massive range extensions for this cloud computing, and people are investing more to take the resources, get the resources, understand how talented they are to groom the algorithms for data management. Now, how an individual can make my data so secure, how much security my cloud is actually trying to do, how can I do my bug fixes. So that's where you should show up your talent and get recruited to any of the biggest organizations, right? Now, if I'm interested to go with the cloud computing career, now what skill set do I have to pursue? The languages are specifically, I have listed on few things only like .NET, Java, Python and SQL. There may be few other scripting languages even. Please ignore me if I've not addressed to, because I've just only listed a very few minimal stuff here, okay. So knowledge is something how relevant you are to script these languages. Scripting these languages do differ, how you actually narrate your application, how you design your application, how you write the logical code there. That is where is a cloud related stuff I'm talking about. Now, expertising on a cloud platform, if you really have, you should have a hands-on certain any of the other clouds. Like if you're if you really say I have a hands-on on AWS cloud, I have a hands-on on Google cloud, now I have worked on AWS Azure cloud, I have worked on Terraform cloud. So you can come back or go to any organization and say that, oh yes, I have worked on AWS SDK, I have worked on Azure SDK, I have worked on Google, I have installed an instance, I have created my own instance, I have talked to the data, I have filtered the data, I have analyzed the data, I can show you the graphs. Yes, you are appreciable to get into the org which you're really talented enough to put in. Now, data handling and database skills. This is what I was just telling in data analytics. That's where comes is data handling and data management, okay. The project management abilities are risk management, reviewing services, and definitely you should have a written on the verbal communication and eagerness to take the new challenges and adapt. And the biggest thing I could say as for my past experience is that how good you are at technical stuff is one point, and how enthused you are to take up the tasks, how enthused you are to dig into the subject, how enthused you are to take up new technologies, understand, groom them, dig them, own them is the biggest challenge for every of the student or every individual or every, even if he is an employer also, if he is working in certain thing, it is not like it's sufficient for him to stick with the same technology which is actually working on. He or she has to still groom himself to grow in the career, to build himself more and more. So that's where your actual skill set comes up and you have to showcase. Now, what does a cloud computing engineer do? Example, you are recruited as a cloud computing engineer. What does he do in the organization, right? So, cloud computer is engineering is responsible for the day-to-day technical cloud computing support. He has to work with the code, develop, design, implement in the cloud software infrastructure. He should definitely maintain a potential to groom that cloud and the application, design it, understand, implement it, test it. This is where we expect the resources to work in that way, like cloud computing engineer. Now, if at all you are senior most and you are a cloud computer architect, cloud architect. Now, what does an architect do? So, architect is slightly a different role when I compare to the cloud computing engineer. So, architect is someone who thinks in a perspective of business scenario. Now, my market is like this. Now, my website is like this. Now, my cloud is already like this in the market. Now, I still have to groom it up, giving few more advantages to my customers. How can I do it? How can I change my cloud? How well versed I can change my cloud? That's where an architect comes and sit back and say. So, there is even a partition in the job responsibilities also, like it can be an architect, it can be a developer, he can be a tester, he can be a validator, he can be a DevOps, he can be of any position. Irrespective of any position, how much thing you take into picture, that is what is a factor which do depend. So, this is what is overall IoT and cloud computing which I was supposed to tell. I thought I should convey a few of the examples. So, depending on my experience, I would definitely like to share you a very precious point is as students or as an engineer or as an upcoming career movers, or if you are trying to move to other companies or trying to own up this as a special career, the best thing in the cloud computing is you will be definitely paid for what you have done, because it's the biggest thing. And in an upcoming new years, it's going to be a biggest blast for the cloud computing technologies, because the data is keeping on increasing second by second. So, how best you manage the data, that much best you will be paid for your technical aspect, that much best you will be paid for everything which you actually do. So, for everything, the major input I would definitely give you, the interest you show, the best you groom yourself, the best you understand yourself, the best you train yourself, and the best you motivate yourself is the best thing. So it's not mandatory that everyone should know everything, but the thing which you know, please expertise in that zone by yourself. So everyone has their own special interest to do. Dig your interest, keep doing it, motivate yourself, keep an interest over it, try learning something, because the internet is the biggest search engine for you. Can search anything in the internet, get back all the info, try to analyze, put it in practical, and make a projects which are realistic to you, understand, so that you will become a best resources or the best individuals, and learn new things and get back with a bright colors in your life. And I wish everyone to be in the best scale of zone in the organization or anywhere which you're expecting your career to be built. So that's all from my side, and hope you have learned few things, and it's a great platform for me to share my thoughts, what exactly cloud computing is on to, and it's the best thing. Hope if it does help you for your career growth, it's actually the best thing for me too. Thank you so much for being with me. Thank you so much. Bye.